Today's session is on a very important topic and one close to my heart, which is the area of ontology adoption. My name is John Breslin. I'm professor at the National University of Ireland, Galway, and we have some exciting speakers today, and we'll have hopefully an interesting discussion with some learnings for you all in terms of how to adopt ontologies. I'm just going to give some housekeeping first of all, and just to mention a couple of things to be aware of. So first of all is that the session is going to be recorded, and the recording will be published and will be available on the website for people who've registered for the event. As you know, there are some talks in parallel, so people who can't attend this talk live may want to watch it later on. During the talks, your microphones and cameras will be automatically deactivated, so for speakers, you can turn those back on as you need to. And after the talks, we're going to have a discussion. We will have some time after the presentations for questions and answers, but we will also have an opportunity for further discussion. And there are a couple of things we want to get out of the session in terms of, you know, how do we adopt ontologies? What's the industrial need? What are the barriers? What kind of tools can we use? You know, what are good practices, good use cases, and so on. So if you have a question, please raise your virtual hand and we will see that, but you can also ask questions using the Q&A function, which you'll see in AirMeet. And, you know, as it says there, just please use the session feed for chats, and for any questions and answers or comments, that's fine. In terms of the session feed for chats, you can use that too. So I suppose just to give some background, you know, Ontology Commons is a European coordination and support action. Our focus area here in today's session is around the area of domain ontologies, industrial domain ontologies, and the harmonization of same. And we are working with various community partners, as well as our members, to help create some guidance and agreements in terms of that harmonization. And it follows a procedure which we're basing it on our top reference ontology and our developed ontology ecosystem toolkit, as well as various outcomes from initiatives from workshops like this and other ongoing work. And the main objective of this focus area is to give us a specification and guidelines for the methodological support of industry-targeted ontology development. And I was speaking to some of our speakers before today's session, and actually this came up in terms of developing an ontology for a particular domain. And it turned out that one of our speakers will tell us later on about how the methodology that they were looking for just didn't really exist, and they had to develop their own. So again, as part of Ontology Commons, we're trying to not just, I suppose, show industry about the importance of ontology development, but also put in the support in terms of methodologies and the reference implementation, which will show how this can be done. And we will have use cases in terms of demonstrators to give working examples of the deployment of the toolkit and the associated methodology. So I suppose for today's session, we want to think about what are the current practices in terms of enabling the adoption of ontologies for various use cases, or even more generally. We're going to talk a little bit about, hopefully, about the pitfalls that prevent or hamper adoption. And we'll also look at the good practice for adoption and how that can be supported by suitable methodologies and tools. So we have three speakers, as I mentioned, as you will have seen from the program. We have Dr. Gianmaria Bullegas. Before each speaker, I will give just an introduction to them and their bio. I won't say too much about the talk because I don't want to assume I know too much, which I don't. And also I want to you know, just leave the speaker to explain the area. Second speaker is Professor Martin Hepp, who will be talking about web methodologies and practice. And the third speaker is Dr. Clement Jonquet, which is going to be about the Onto portal technology. And this actually follows on from a talk that he gave earlier this year in March. So I'm delighted to be here as the chair. And also we have our rapporteur, who is also from NUI Galway, Dr. Lan Yang, who you will see as well on the channel. So without further ado, I just wanted to introduce our first speaker. It's Gianmaria Bullegas, who is the CEO of Perpetual Labs. I'm quite excited to hear about this talk because, you know, I'm a big advocate of startups, and it's exciting to see a startup working in the ontology and model-based engineering space. Perpetual are developing tools in the aerospace and automotive industries, and I think the key thing there is around that idea of having to deliver on the promises of ontologies and model-based engineering, and also developing the associated methodologies that are required. So without any further explanation of the abstract, Gianmaria, I will hand over to you, and I'm just going to stop sharing here, and hopefully you can take over the screen. So welcome, Gianmaria.
Hi, thank you. Thank you, John. Can you hear me?
We can.
Excellent. Thanks all for the introduction. I'm going to share my screen, and hopefully everything will go smoothly. Yes. Okay. Can you see my presentation?
It's coming up now. There we can. Perfect.
Excellent. So good afternoon, everybody. My name is Gianmaria, and I work in Perpetual Labs, which is a young startup that is dedicated to create what we call DevOps tools for cyber physical systems. And today I'm gonna present our experience using ontology to support the systems engineering process related to the design of a space mission. And we have called these semantic systems engineering, and it's gonna become evident in a minute why, and the application to the use case, which is this large aperture space telescope. So without further ado, let me explain what we mean by semantic systems engineering. So as we probably all know, we are all familiar, I guess, with the evolution of the web, from the web of documents, then the web of data, and now with the adoption of the semantic web standard, RDF, OWL, this idea of the semantic web. We think that something similar is happening in the world of systems engineering for complex industrial systems. Traditionally, systems engineering was done in a document-based way, and we had document-centric system engineering. Over the last 15 years, there has been a transition to model-based and data-centric systems engineering. But we think there is still a problem there, that data by itself is not really enough. You need to be able to capture the relationship between the data that really make the knowledge apparent. And we have called these transition semantic systems engineering. We've called this idea semantic systems engineering. And with this idea, is the challenge, I think, of semantic systems engineering is what we call digital continuity. Digital continuity is, as defined by the European Space Agency, is really about the capability to capture the semantic links between the different bits of information about our system that are scattered, are contained in different information artifacts, and make this link apparent and traceable across the three dimensions of systems engineering, which are across disciplines, throughout the life cycle of a system, and along the supply chain. So this is essentially what we have been trying to do in this project. Let me introduce you to our use case. This is the LAST mission. The LAST stands for Large Aperture Space Telescope, and is as you can see is in orbit space telescope with an aperture of over 25 meters. It has a modular architecture, which means that the telescope structure can be assembled in space by a robotic system that are these robotic arms called e-walkers. And this enables to essentially deploy structures that could not be contained in a single space mission, like the typical space telescopes of today, like Hubble, like the Hubble telescope. And this mission is being designed at the moment by a team of PhD students at the University of Lincoln. So as you can imagine, it's a very complex system design and a complex systems engineering process. So we wanted to develop an ontological framework that would allow us to support the entire design process of the last mission. And we came up with this system engineering, semantic systems engineering ontology. Now, the ontology at the top has a structure that can be mapped to a top-level ontology. For the moment, we are using BFO, but we can be compatible with other top-level ontologies. And then we have a modular structure where we have constructed 4 modules for the time being. One that is focused on the process, the systems engineering process itself, so how to model the different activities that needs to be carried out during the design of a complex system, and the different information artifacts and the different types of information that are produced. Then we have what we call domain lexicon, which is the vocabulary that we need to model the domain-specific stuff in our use case. In this case, we're talking about the space domain, so we have things like orbit, radiation, space objects, and this kind of stuff. Then we have a modeling and simulation module in our ontology that is about capturing the different type of artifacts, information artifacts that are produced in the design of a complex system. I'm talking like CAD files, simulation files like MATLAB simulation, CFD simulation, and whatever, like you can imagine that there is a vast array of different modeling and simulation tools that the engineers use. And the last part is about what we call organization module, which is about modeling the different aspects of working together in an organization that is needed to bring together a complex system. And in creating these different modules, we have trying to take from well-established sources, like standards like the ISO 29148, the system engineering standards, and other, for example, the ECCS standard from ESA, and the common core sets of ontology. So we're trying to reuse as much as possible from established ontologies and from published standards. So yeah, the ontology is then organized in patterns, and these are essentially modeling paradigms, if you want, that are meant to showcase how the ontology is meant to be used. And without too much spending too much time on this, I just want to jump in directly to some examples. And here you can see how then we can use our ontological framework to capture different aspects of our system design. In this case, we are capturing the architecture of the physical architecture of the system, with the spacecraft, the e-walker, which is the robotic arm that manipulates the different modules of the telescope, and the different physical connection and interface between these elements. And this is a typical, very typical activity in a system engineering process, defining the system architecture, the physical architecture of your system. And this is how it can be captured in our ontological framework. Similarly, this is another example of how we can use the semantic system engineering framework to capture the traceability of requirements, and how requirement can be verified by different physical components of our system, and through simulation. And sorry, I'm gonna have to drink a little bit of water. Apologies about that. I was saying, like, requirements and the traceability of requirements, and the connection of requirements with the physical architecture, the logical architecture, the functional architecture of your system, and how you can verify requirements through simulation or through testing. And this can be captured, the traceability of this can be captured in our semantic systems engineering ontology. Now, I should specify that we are not ontology developers. We created these, the semantic system engineering ontology, and we applied to these use case mostly because we needed something to play with. Because at the heart, we are tool developers, and the tool that we are developing is called GraphSF. GraphSF stands for Graph System Factory. It's a web-based collaborative platform that is meant to allow teams of engineers and large distributed teams to collaboratively design complex systems and not just share the data that is involved in the design of the system, but also being able to capture the semantics of that data and manage that semantics in a formal way using ontologies and knowledge bases. This platform has a knowledge graph space in which the user can define this semantic connection, essentially model the system engineering process, the information artifact, the connection between these, and create and query these large knowledge graph in a collaborative way. And then the platform has native support for all the typical information artifacts that are used in a complex engineering system. I'm talking, for example, CAD files and different types of simulation artifacts, and integrate these directly with the knowledge graph. So being able to formally model the knowledge of the system and then directly connect this knowledge to the information artifact typically used in a systems engineering environment in what we call a semantic tagging system. And all of these is under version control with the same functionalities that you have in a typical Git environment. You have this functionality of version control, both for the artifacts, for the data, and for the metadata, for the knowledge graph. And the two things always go in unison. And so in terms of the next step, we see our platform GraphSF as a collaborative platform, really the nexus of collaboration between the different disciplines that typically have to interact to develop a complex cyber-physical system. And I'm talking about software development, hardware development, manufacturing, systems engineering, project management, and business strategy, kind of collaborating by sharing data, but also by sharing the metadata, the semantic relationship between the data on a unified platform that gives the tool to manage both things at the same time. And with that, I conclude my talk, and I'd be happy to take any question. I believe I've been quite quick, so we should have ample time.
That's great, Gianmaria. Thank you very much, and very interesting presentation. I think a nice combination of the needs there in terms of the last mission use case, but also this more general knowledge modeling platform in GraphSF. Actually, we speakers earlier on in one of the earlier sessions was talking about this kind of circles as a way of visualizing ontologies, and it was nice to see a kind of a link to your explorer there in terms of visualizing the different terms. So any questions from the audience? I'm just going to move to the Q&A panel and just see what we have here. Okay, so there is a question from Roberto. It says a long-term effort for. Let me see if I can put this on the screen. I don't know how I can put this on the screen. Christine, are you up to? Here we go. That's great. Thanks.
Yeah, I've seen that.
I can stop reading. Okay. So it's an effort which I've been seeking support for years. Perhaps you consider this. So there's ontology for space. I guess, Gianmaria, like obviously, you're talking probably about supply chain and components that eventually end up in constructing various types of systems like the spacecraft. A space ontology will be quite a big thing, and I haven't looked at the ontology that Roberto was talking about, but
there are several undertakings related to space ontologies, and at various degrees of maturity that I know. But as I said, we are not ontology developers. We want to develop a tool that is in a way agnostic and can support many different paradigms.
Yeah, and tell me, because I suppose one related thing is when somebody's constructing an ontology for a domain, what do you recommend in terms of how people can reuse or link into something like, let's say, for example, a lot of the terms you needed were in this space ontology, but you needed to create your own very specific thing to space for or supply chain or inventory for supply chain for the space domain. So in your tool, would you say somebody should be creating the ontology from scratch, or they should link into?
No, we have the tool supports ontology import, and so you can import your own, and as a basic ontology editor as well, so you can interact and modify if you need. And we at the moment we load our own ontology when the user initializes a new project, can decide what modules to import. So we envision modular architecture for this, and ultimately potentially libraries of ontologies that are compatible with each other and can be imported in the same project.
Okay, super.
But yeah, ultimately the issue that we found in that context is that the language and the formalism that you want to support and the reasoning that you want to do kind of there is a usual trade-off between expressivity and actual usability. So we ended up creating kind of a very specific way of modeling. At the moment we are RDF OWL based. We ended up with a very specific way of modeling stuff because we needed reification of relationships. And we needed an easy way to distinguish between entities that are important and kind of things that are attributes. And so we developed these modeling patterns that we kind of enforce in the way that the tool develops the ontology.
Okay. And you have those demonstrators then as well of the the showcase of the modeling paradigms you mentioned earlier on, where people can see how you've then created those models. Perfect. So with 2 more questions there. We'll try and answer them because otherwise they can come up later on anyway in the discussion. Do you have any publication about your ontology? Is there a publication about it, Gianmaria?
Yes, there is a publication which goes. We recently presented a conference promoted by the European Space Agency, and there is a publication related to that. Okay. But we aim to publish this stuff on GitHub as well soon.
Okay, perfect. And the last one there from there's actually another from Martin. Maybe Martin, we can do this as well in the session. But have you had any challenges in terms of the modeling simulation ontology to mapping it to BFO?
I could talk about that for an hour probably. Yes, many of them, and the main problem of the every realist top level ontology is that you describe the word, and then in the word you have information artifacts that talk about the word, and then you kind of have inside information artifact you have information objects, and then you end up having to recreate all the machinery that you already created to describe the word in the world of information objects that are inside information artifacts, and the thing becomes recursive. So yeah, it's complicated.
Okay, and then the last one there from Martin: have you considered moving from RDFL to SHACL, shapes-based?
Yes, definitely. We are. That is something that actually we are doing right now.
Okay, perfect. Great. Gianmaria, thank you very much. And a very interesting presentation. I'm sure we're going to come back to some of those points in the discussion later on as well. So thank you very much.
Thanks to you. Bye.
Okay, so I'm going to just share the biography of our next speaker. So we're delighted to have as our second speaker Martin Hepp. I've been aware of Martin's work for many years from my previous life in Derry. Martin is a professor in Munich and also CEO of Hepp Research. And he's, I suppose, very well known for developing various ontology efforts in the product domain, but most particularly the GoodRelations vocabulary, which has been the e-commerce component of schema.org since for 10 years now. So Martin, without any further ado, I'm not going to say much more because I don't want to ruin your presentation, but or give any preview of what you might be talking about. I haven't seen it anyway, so I'll hand over to you, Martin, if that's okay. And thank you very much again for joining us today.
Yeah, thanks. I hope you can see my...
We can see your full screen, but if you go into presenter mode, hopefully we'll be able to see your presenter mode in a minute.
This way?
It's gone again, but maybe try once more. It's not sharing at the moment.
Okay, so I think, just a second, change it to kiosk mode because I thought it's more useful. Just 1 second, present by speaker, full screen, and then probably stopping the sharing. Share screen window, this one. Better now? It's not yet full screen, but
it's not sharing at all. Oh, here we go. Yep, perfect. That's great, Martin. Thank you.
Okay, so I try to be really concise, not rushing, but the overall topic of this session was, I think, how to create ontologies and make them adopted, make them popular. And it's not really the focus of what I want to be talking about, but the 2 guidelines that basically helped GoodRelations become a success was, from the very beginning on, a very simple economic principle. Make it as easy as possible for people to adopt GoodRelations. We developed dozens of open source software pieces so that, for instance, from shops, you could directly export your database content to GoodRelations. So many people never knew they were using GoodRelations, just their service provider had installed a plugin to their shop software, and then they were publishing GoodRelations data, all compliant. The second thing is make it as rewarding as possible to use your ontology in an economic sense. So creating tangible, measurable incentives for publishing respective data according to your ontology, where the easiest way is to convince large relevant consumers to use it. This is why I've spent a lot of effort over more than a decade to make big search engines consider at least parts of the ontology so that people have an incentive to use it. So these are basically the basic economic principles. And the third thing we should probably speak about is that these incentives are not necessarily evenly split among adopters. So for instance, some people have to provide the data and others will harvest and use it. And economically, without any kind of compensation, this will not work. Now, the core of my talk is, what did I learn from trying to build ontologies that span every industry in every economic system across the globe for any stage of the supply chain, so from raw materials to after-sales services and the like. First of all, a very old illustration, a figure from Nicola Guarino's 1998 paper. Basically, if you want to use ontologies for systems interoperability, be it human systems or computer systems or human-computer hybrids, is basically you have a set, this is the left one, IBL, and you have another set, and 2 systems basically can communicate only if the entities materialized as data are in the intersection of the 2 set definitions. So basically, if person A judges something to be an espresso and someone else shares this assessment, then they can make a business transaction about this. But if they disagree, you will no longer have interoperability. This can be seen in a fairly abstract way, so whether something is a risk or whether something is a book and the like. But the basic thing is interoperability happens if the set definitions from the person publishing the data or relating entities to, for instance, a type, matches the one of the receiving or processing system. We'll get to that in more detail. So an ideal ontology takes place just in this intersection. In reality, even ontologies do not guarantee this, so it becomes a probabilistic game that the type definition by the publisher matches the type definition of the consumer. And the actual technical contribution that ontologies do to information interchange is that they improve the reliability of type information, kind of increasing the probability that an entity typed as a member of class hotel, for instance, would also be classified as this by the receiving or processing system and all of its stakeholders. So basically that you communicate in the intersection between the two subjective set definitions of publisher and consumer, or end publishers and end consumers. So this is what ontologies really do, is they make type membership information more reliable. They increase the likelihood of compatible data processing on the basis of types. And connected to this is it's actually impossible to guarantee that we have the same type definition, because type definitions are always approximations and hence incomplete. But at least it's required that the computational operations over the data are compatible between publishers and consumers of data. For instance, that filtering, ranking, ordering, computations, any kind of computational operations over the data that will take place at the consumer side of the data that in this aspect, the type definitions of publisher and consumer are compatible. So you maybe know two classic examples. We have a query, how many books by Shakespeare are in our bookstore? If the database includes entities that are book copies and some book titles, then the query can never be correct, because it doesn't mean how many books by Shakespeare are in our bookstore mean how many different titles are there, or how many different copies, or how many different editions and the likes. So any kind of computational operations over data by the recipient can only be guaranteed to work if, in this respect, the type definitions of the origin and the destination of the data are compatible. A more pragmatic example is the query, which are the 10 most profitable companies? If you think that defining revenues or profit in economic terms is largely influenced by bookkeeping, laws, and also several choices like tax evasion strategies and the like that, very different ways of determining the profit of a company at the end of a year. So if you merge data from multiple sources and then they compute the profit in different terms, then a simple ordering, like by most profitable, profit divided by turnover or whatever, will no longer be guaranteed to work, will become unpredictable. Now, so in essence, ontologies help us improve the likelihood that the type assigned, represented in the data, assigned to an entity, is compatible with our types and the associated processing steps. Now, in our research, we try to look into which properties of the ontology and the data and the domain determine these probabilities. And actually, this is open research. The number of individuals of that type has an influence. If people are familiar with, for instance, that class, then they will classify more reliably, and there will be more consensus about the meaning. If you have very exotic words or types, like exotic fruits or exotic dishes also, then the likelihood for a random N-to-M information data transfer will be reduced. Then the cognitive skills of involved humans will play a role, like, for instance, how educated they are, how trained are they to see subtle distinctions, like book copy versus book title. So many of these aspects are these properties that influence basically the benefit, the effect of an ontology, are open research. And there are a few fallacies that have been in existence for 2 decades now in this ontology community, not in all branches, but are still very, very frequently heard. And that first is, formal specifications don't guarantee correct usage. There have been discussions about whether you should have lots of formal axioms, lots of formal logic in ontology definitions, a very expressive ontology formalism, or rather lightweight ones like textual definitions, examples, even multimedia elements. Now, the thing is, axiomatic definitions in the ontology specification alone do not, there's no serious evidence that they improve the reliability of type membership in information interchange scenarios. Because even if you have 200 axioms that define what a cappuccino is and isn't, it doesn't really influence the quality of data if people use that ontology to transfer or to lift data from a relational database according to some heuristics to class names. The second fallacy is that web ontologies or ontologies at scale in general would allow for guaranteed automated processing so that the raw data could, for instance, be used for meaningful Sparkle queries or processing. In most cases, the data resulting from the use of web ontologies at scale is something that I call proto-data. It is data, but the step of lifting, cleansing, entity consolidation is significant. Now, very few people challenge the assumption that web data need to be cleansed and lifted, but this has often been regarded as one, small housekeeping step for using the data. And my position is that actually the lift from proto-data to data ready for consumption is an essential step, because it's context dependent, and the larger the number of stakeholders gets, the larger the amount of people gets, and the larger the period of time during which the data is being produced and consumed, the less likely it will become that you can make anything meaningful over the raw data that you, for instance, crawl from the web. A very recommended reading on this is an old paper by Stuart Madnick from the MIT, The Interplay of Data Quality and Data Semantics, where he basically says that data quality and data semantics are two sides of the same coin. That if people get, if you have unreliable type membership, you cannot really say whether this is a lack of precision in the definition of data semantics or of data quality, if they use, for instance, the type membership assignments in incompatible ways. I also wrote a paper quite long ago, like 16 years ago, that tried to highlight the economic and social constraints that you have when you try to design ontologies that are used by many people on a large scale. It's also important for people who come from environments with more controlled, from a more database prone environment, that schemas and web ontologies and database schemas are two forms of schemas, of structures that, of specifications that define the structures, the relationships, and the data semantics of elements in a representation. That in traditional databases, these schemas are very close to the databases, to the representation, and to the processing. So the database schema is very close to the database that holds the actual instance data. Web ontologies are very often quite in the middle between humans making judgment, producing data, and the actual consumption. So they are not as tightly coupled to the actual consolidated database or knowledge base. So there's a lot. There are lots more additional degrees of freedom between those two. Now, we for instance tried to analyze certain ways that influence the reliability or the efficiency of ontologies, and one thing we analyzed was how well can the target audiences understand and apply the conceptual distinctions in the ontology. For instance, asking people whether they can consistently classify book copies and book titles, so that there is consensus in this, or making the realizing, understanding the distinction between a web page and an entity described by the page, the Wikipedia page about John Lennon and John Lennon as a person, or the abstract concept of something versus the materialization of that, or for instance, legal entities versus shop location. Is local business the legal entity, or is it the place? If the pizza place is taken over for someone else, is it the same pizza? Or is it a completely new one in this? So trying to analyze scientifically with empirical science which distinctions that we use very frequently in ontology formalisms are consistently understood and applied by the humans that influence the design of systems or consume the data. In another paper, we could also analyze, we could also actually show that the quality of definitions, that the resonance with existing categories in the minds of human users has a much stronger influence than the length or comprehensiveness of ontology documentation features. So for instance, if you define a class that's called mammal, the likelihood of people being able to produce and consume data in an interoperable way is much bigger than as compared to a class that is kind of rarely used, like a class foo. No matter how many axioms you add, no matter whether you add examples and the like. So the resonance with the established conceptual structures in the minds of users, the resonance is very, very important. So in a sense, it may be that in ontology designing, we have not full freedom about how to shape classes just on the basis of what we want to do with the data, but must instead investigate the conceptual distinctions that are readily available in the minds of users and tap those, or in the data. For the more computer science-based view, it's also not the ontology determines the reliability of the type membership, but much stronger, to a much larger degree, for instance, the distinctions in existing database structures. For instance, if shop software makes a distinction between product and service, then people can likely populate respective classes from an ontology properly. If the databases in use in common off-the-shelf software don't, it's highly unlikely, no matter how richly you axiommatize the ontology. So again, it's a completely open research whether, to which degree we can shape the classes, the types, the properties in an ontology, and which influence the documentation has as compared to latently or explicitly available distinctions in the minds of human users or in old systems. Then one task when building ontologies is, of course, related to the entropy. Classes in an ontology where membership or types that can be inferred from the data alone by learning approaches or others are not as valuable as those that can be preserved in the transfer between source and destination of data. So basically, a class that is difficult to reconstruct, a class membership that's difficult to reconstruct, but useful for many purposes for the data processing, makes more sense in ontology as one that can be readily derived from other classes or from features in the data, for instance, from literal values and the like. And this is basically nothing but the information entropy of your class. So how much, if you know that class membership, how much does it help you to reduce how much does it help you to decide which operations you can do over this data? So for instance, if you mark a web page in schema.org as a web page, then the gain is very limited. If products are, or in a web shop are marked as products versus services, or a product is marked as being either a product model, like a template, or a product instance, then you can, then this is something that the recipient could hardly reconstruct. What we also investigated is how we can monitor the live feedback on the quality of the membership function of your ontology. So you can see an ontology as a specification as the one extreme. Okay, I publish my old file and HTML and whatever, and I can look into the data and see, okay, how is my ontology being used? And in between those two extremes are, in my opinion, useful ontologies that contribute to data interoperability. Now, when you build ontologies, quickly to sum this up, you have basically 5 challenges. You want to improve the reliability of type membership of entities information processing. You have to find types that provide sufficient distinctions for algorithmic information processing so that you minimize reclassification tasks at the recipient side. You need to help the recipient you need to provide enough entropy so that the algorithm or the computer-based solution working with the data can process the data without reclassification. The same holds for data granularity, like how many subfields you define. Note there's also a cost trade-off. Having a highly granular address is useful for processing, but it's more costly to populate, like street name and street number in 2 fields, more useful for processing, for sorting by a street number, but more costly for populating. And also, if the ontology prescribes a higher granularity, then the data quality may go down because people feel annoyed or don't invest enough to, or are not able to populate the data properly. Then you need to find types that can be populated from existing data sources without a lot of reclassification tasks. So like classes that fit at least to the database structures of popular existing software. And you need to find conceptual distinctions that can be reliably mastered by the human stakeholders of the system. Okay, so these are, in my opinion, the more challenges. The biggest challenges when you want to build useful ontologies. And if the community of users gets large and the data sources and consumers increase, then these challenges, of course, take place at a bigger scale. There's an old term for some of these problems called ontology perspicuity. This is from really old papers. And it's basically the richness of the communication channel between the group of people creating the ontology and the group of people that use the ontology. And historically, the assumption was if you publish an old file in HTML and maybe a user's guide and a quick start, people will understand your ontology and it will guarantee correct data. But as I've tried to argue, the type membership, the quality of the type membership is only influenced by the ontology, but not guaranteed, because many other contextual variables influence that. Then you have ontology economics, a very under-researched field. A large and expressive ontology is more useful. You can automate more information processing, but it's also more costly to deploy. There are less people who are willing to spend the effort of learning it, getting familiar with that. So there's a trade-off between how rich and useful your ontology is and how many people will spend the effort for learning and using your ontology. And then there's the problem of maintenance and dynamics, in particular if you talk about domain ontologies. Adding new distinctions that evolve in reality takes time, and there can be many bottlenecks like release cycles or fixed delays, committee meetings, whatever, that determine the speed of evolution of the ontology. And depending on how fast or slow your ontology engineering cycles are in comparison to the conceptual dynamics in reality, the larger will be the gap, the lack of coverage of your ontology in comparison to what's really in the classes and properties that are really relevant in the domain. And this figure here underestimates actually the relevance of these missing elements in the ontology, because very often the new conceptual distinctions that are not yet in your domain ontology are often those that are most valuable in economic terms. Think of new materials in materials science. If you don't have a class for it, but you want to find someone who has the skills to process this material or supply respective things, then these missing novel conceptual distinctions from reality that are not yet in your ontology have a much larger economic impact. And of course, there will always be a gap, and how big it is just a trade-off between, or it's just basically a trade-off between the dynamics in the domain versus the speed of ontology engineering and updating. Okay.
Martin, we're out of time, I'm afraid. So if you want to wrap up, thanks.
I wrap up in here. So basically, there are several ways of like trying to build better ontologies for large use cases, and I can link to the respective work. But building an ontology, the ability to specify types in an ontology is just one of many variables that influence the quality, reliability, cost, number of exceptions of data interchange processes. And it becomes more difficult the more stakeholders are involved, because the axiomatic part of an ontology does not guarantee a proper type membership. That was it from my side. I'm not sure. Yeah. So
thank you, Martin. Excellent. And I think you covered so much. I was really interested in some of the comments you made there at the end around perspicuity, which is a word you have to think about before you say, because it's it's difficult to pronounce. And also, ontology economics, maintenance, and dynamics. I'm going to I'll come back to I have some questions for you myself. I'll come back to them in the discussion. But maybe what we might do is just take the two questions there from Enrico. Well, one is a comment and one is a question, I suppose. Or actually, maybe they're both comments, but I'm not sure, Christina or Rita, can you show these on the screen? The first one is about the impossibility of using heterogeneous, noisy data. It depends on what you're doing, the size of the data. If you have large scale, noisy, redundant data, you can still do stuff. So, yeah, what's your take on that?
So basically, I think Enrico and I are in alignment in here. Of course, noisy data, I mean, you can, with data, you can always do stuff with data. The question is not whether you can process it, but the number of exceptions you have, the guarantees you can give on the processing. And yes, of course, if you have large-scale noisy data, then the entropy that is in the data may be sufficient to basically process it. So maybe my point was not fully clear. I also try to align our ontology work, like designing conceptual structures that have a good philosophical grounding, that are reusable, make good distinctions on one hand, versus learning-based approaches that they basically try to take the entropy that is available in the data to make the distinctions. And any learning-based approach, of course, the more data you have, the better is your sample of the respective domain. And then even for less frequent distinctions, you may have enough entropy in the data. So there's no, I don't think there's a disagreement in here. What I meant is basically ontologies came from a very controlled community. I mean, when ontologies were invented in computer science 20 years ago, it was about making knowledge representations more interoperable in small elite AI communities, hundreds of people who met each other at conferences, read each other's papers. They had a lot of shared context. So then you took that term to the web, where the assumption is that ontology can increase interoperability between millions of people who never ever meet each other and have a lot less of shared context. And then what ontologies can do may be something completely different to what they were intended to 20 years ago.
Yeah, absolutely. And I think that move from where the people designing ontologies, or even designing the formalisms for ontologies, and the people using them in terms of the conceptual distinctions that they have and what they understand by different terms, is one that's probably underexplored. And I think there's probably less formal, bit of work needs to be done. I'm sorry, there needs to be more work done on the less formal definition, and more on the understanding of people's understanding of terms, as you pointed out, in terms of that's the perspicuity thing there. And again, something I suppose intuitively, or kind of in the back of my mind, thought of, but haven't thought about how to formalize a brainstorming process to extract those terms. Martin, thank you again. We'll move on to our next speaker, if that's okay, because I want to make sure we have enough time at the end for questions as well. And thanks. We've lots to talk about, but let me just give you a quick overview of Clement's bio, and I have to do a bit of swapping of screens here, sorry. So welcome, Clement. Again, thanks for joining us today. Clement is based in Montpellier. He is a research scientist at INRAE in the MISTIA Research Unit, and also a member of LIRMM. He's had various expertise in terms of working with Stanford's biomedical BMIR group, and many years of experience in developing ontologies. And at present, he's working quite a lot in the agronomy and food and plant sciences domain, where he's leading the ANR D2 CAB project. So, Clement, I'm going to let you talk about OntoPortal without, again, spoiling anything in your presentation. Again, thanks very much for joining us today.
Thanks. Give me 1 second to present the screen. Do you guys see my screen now?
We can. Oh. We can indeed. Perfect.
And you see the full screen, not the notes?
We can see the full screen, yeah.
Okay, cool. Let's go with this.
All good.
Okay, well, let me just go back. Yeah. So, hi everyone. I try to make it quick, so wanted to bring you back a little bit in the technological and a little bit more of concrete stuff, ways of sharing and adopting ontologies. I mean, so we come in this presentation after the ontology development step, where we want to share and serve and have those ontology being used by others. So this talk is about OntoPortal technology. This is kind of an excerpt from the March 2021 Commons workshop, where I had a longer presentation presenting the ontology repositories and feedback, a return of experience on 2 projects that I will also cite there. So you'll find on slide share the longer presentation, and I've made a few updates there. So there is a bunch of issues with ontologies that you may have, that you know. They are spread out, different formats, different size, with different structure, increasing numbers. They are overlapping. So the needs of ontology repository becomes more and more important for different communities. If you build an ontology, or do you let the world know you need an ontology? Where do you get it? Or do you know whether an ontology is any good? Or you find data related to your ontology, or you could leverage your ontology to enable new science in general. Well, the main question is how you could use those ontologies without being the one managing them. So that's why we develop ontology repositories, and why they have been identified a few years after starting the ontology development phase, important issues when developing ontology. And one of my arguments for a few years is that developing ontologies repositories help them to make them fair, as we need to have fair data. Then those fair data relies on fair vocabulary by the FAIR principle, and so those vocabularies and ontologies need themselves to be fair. Ontology repositories help achieve that goal. The screenshots that you see here for each of the letters come from the OntoPortal prototype that I will also illustrate, that help us to find them, to access them through different APIs and Sparkle endpoints, make them more interoperable, describe them with standards, and then overall reuse them more. So there are different challenges for ontology repositories that I'm not going to describe in detail here. I've been describing them in a manuscript 2 years ago, and so I will point you to that reference there. But working on that domain of research opens different questions related to alignments, metadata, annotations, link data, and then the question of interoperability, all of that. So a lot of this history start with the NCBio bioportal resource that was developed originally at Stanford University by the National Center for Biomedical Ontology, which the goal of having, it was a 2006-2007 project with the goal of finding all the ontologies available in a domain somewhere, make them accessible, usable, and have a place where they can be published, download, browse, search, comment, where the content of the ontology will be aligned. So you will find a bunch of services accessible in bioportal. Those services will allow primarily to work with ontologies, but also to work with the mappings between those ontologies and start plugging in new ontologies in systems with widgets, and then using those ontologies for annotation, especially annotation of text data. And when annotation was actually processed, then you could use your ontology repository to access data. Those was the five really important pillars of the bioportal technology originally, and those missions stays available. And all of that with the vision of adopting a web approach where everything was available online, but also through an API. And so the best slide to illustrate the impact of the bioportal project a few years ago is that illustration of the link Open Data Cloud that a lot of people in our domain knows, showing the web of data with those bubbles interconnecting data sets be published in RDF, including ontologies. And when the biomedical and CBO bioportal data was uploaded into the cloud, we end up with that little ads on in pink there in 2013, which shows and illustrates the impact of gathering different ontologies in a domain. So that was the beginning of the story. But then for a few years, more than 5-6 years now, we are working on generalizing and reusing the technology in different domains. Will be in the biomedical domain, but for other languages, for example, in French and Chinese, but also the agronomy, agriculture domain, the AgroPortal project, and more recently the EcoPortal project in ecology and biodiversity. So we are working on that. So I'll be describing a little bit of some of the features of the things we've been doing, working, for example, on a French version of bioportal. The motivation of having a French version was that there was a few semantic resources, ontologies, and terminologies that were only available in French, and some of them were also multilingual, but bioportal was not handling the French aspect. So we wanted to be sure that we could have a place where the French actors will find their resources, and for example also use the annotator service for French text. So we have a lot of French text, biomedical text in French, sorry, for example in clinical data, and that was useful to develop an ontology-based annotation tool for those texts. That was one of the motivation of this project. Then another project that I'm still leading with INRAE now is the AgroPortal, an ontology repository for agronomy, food and plant science, and biodiversity. So originally, the key idea was to say, look, if the success of bioportal could be brought to other communities, then let's try to make it happen with the same technology to reuse and save time and reuse the same technology, and then provide new stuff and enable new science in the agronomy domain. So we end up building AgroPortal, and we have now around 130 ontologies in that portal. And the more ontologies we had in the portal, the complex the project becomes. But then it is also very challenging and provides new feedbacks and new use cases. Something interesting is that I've been manipulating those two figures, the numbers of ontologies and the numbers of candidates, for about 5 years, and the numbers of ontologies in the portal increase regularly, but the numbers of ontology candidates stays the same, which means that the more I talk or the more I present the AgroPortal, I discover more and more ontologies that are being interesting in being loaded, and so we are still in the process of including new ontologies in the repository. So the idea of a repository is that you can access the contents. So this is not only a library where you access metadata describing the resources, but here you can search, for example, soil profile will return you matches in different ontologies, and you can include that content in some of your website, or use those tree widgets and things like that helps you connect to the ontology terms and then connect to the URIs that are on the back. So an important piece of work that we've been doing for years is the extension of the description, metadata description of ontologies in AgroPortal, with the vision that we should standardize more the way we describe ontologies, and so we start building on state-of-the-art resources like OMV and schema.org and DCAT and all of that in a few years ago, in order to kind of enable a better description of the ontology inside our portal. So now we have those features, and the idea is to encourage the users to get that metadata back and put that back in their file when they develop ontologies. And the fact of enriching the ontology metadata for each ontology and harmonizing that metadata for each ontology allow us to have that page that I call the landscape page that shows us stuff, information about the community by looking at the metadata, but not for an ontology, but for all the ontologies in the portal. So it will show you the most active communities, the most active people or organization, the more important topics, the language that are being used, the format, things like that. All of that showing, illustrating the landscape of those ontologies in a domain. Something that we are currently working on is a tool for fairness assessment that will be released in AgroPortal in a few weeks now. We have been developing a fairness assessment tool that helps using the standard metadata, figuring out if the FAIR principles are respected for the ontologies. So we are now concretely measuring and evaluating the fairness of an ontology inside the portal. So we are taking the first slide that I showed you a few minutes ago and making it a reality, and with an automatic fairness assessment tool, something that will explain with different questions, around 65 questions, will explain why an ontology is considered more fair than another, and then a fair score that will help order and select and compare ontologies in AgroPortal. So a work in progress is also in the context of the Research Data Alliance, in collaboration also with the European project FAIRisFair. We are working on a DCAT extension or profile for semantic artifacts, so ontologies, but taking with a broader term, and in which we include the notion of ontology repository and catalogs and distribution, all of that, in order to standardize the metadata of ontology repositories and ontology themselves inside those repositories. So on these, we are getting inspired from DCAT, and we are working on making sure that if such a standard is being developed, it can be adopted by different ontology repository providers. So finally, to wrap up, I wanted to talk today about what we call the OntoPortal Alliance. So Stanford University, us at INRAE and Montpellier, and then also LifeWatch, but then a few other partners also are pushing to develop. A few other partners, for example, at Fraunhofer with MacPortal, but also in China with NetPortal, and also industrial partners. We are joining together in what we call the Alliance, where we synchronize our efforts, mutualizing our research and development activities to build a better software, better environment for sharing ontologies. And so this is definitely of interest, the idea of developing a community portal for different groups, with the overall vision of being sure that the efforts that are being included in an open source project allow us to go and vision long-term support for that. So in summary, I've been talking about the FAIR ontologies through different features and ontology repositories. I've illustrated some of them with AgroPortal and present you the OntoPortal Alliance. And yeah, that's more or less what I wanted to talk today for adoption and sharing ontologies. And then this is acknowledgement of the support for this project.
Merci beaucoup, Clement. That's perfect. Thank you very much. Very interesting presentation, and I love the approach there to expand out what is basically a great use case through the bioportal to more generic platform, but also to use it for the same domain in other countries, but then other domains in many countries. So it's really interesting. What we might do is, in the interest of time, is we'll go straight into our discussion panel session, and I will start with some questions for you, Clement. To make things a little bit easier, I'm going to follow on from your presentation, and I'm actually going to share my questions on screen here so you can all see them. If you're okay to stop presenting, I will share. I'll share the question I'm going to ask you. That'll give some advance notice to the other panelists as well. So here's what I've lined up, and I think I know there's some more questions in the chat as well, and we can hopefully get to those as well. Maybe Clement, just to start with you, some good practice in terms of adopting ontologies, and maybe you can talk about the because I suppose you've given us the examples there of how the portal can be adapted to other areas. What do you see as, if you were to pick out some of the let's say the ontologies that have been promoted through AgroPortal or EcoPortal or BioPortal, which ones do you think have got traction because of the portal existing?
Well, so there is different aspect to this question. I mean, we have observed different success stories in ontologies. I mean, no one can make a presentation without mentioning the biomedical domain or the OboFoundry success that have been built on top of, for 20 years ago, gene ontology, which is considered as one of the success story in ontology. For sure.
Clement, what would you define as, the second question there is, what would you define as being a success? Maybe we could start with that.
Well,
yeah.
So they have been sharing principles for designing their ontologies, and they have been also working with their community and through different solutions and software that were offered to them. So right now, what we figure out also is that different communities will come, especially with AgroPortal, will come with different needs and will not recognize themselves in things that have been done in previous communities. So I think it was important also to adopt to make a step further, to go to join to meet those communities. And I think that have enhanced the adoption of ontologies and semantic resource in general. Here, I can also, I think Ontology Commons and the manufacturing and material community are also at that stage where it makes sense to go together and also have technology providers and experience community like that coming in with them to and adopt with them, because otherwise there is no generic solution that I believe in that will fit everything.
Yeah, have you thought about kind of taking the OntoPortal idea and you're obviously looking at the agro domain and the eco-environmental domain. Is there a sort of an application in the manufacturing domain, for example, or manufacturing of materials like ManuPortal or?
So so you've seen in my presentation, we've been discussing with Ontology Commons for a few years now. Have meetings to come in the next weeks with AD, but we've also been in the loop also with people at Fraunhofer that have been developing MatPortal. So MatPortal is a tool that is now online on matportal.org or something like that.
Yeah.
It's pushed for material sciences.
Perfect.
Ontology Commons goes further that with the industry challenge and all that, but there is a need. AD also mentioned, or someone did mention, the industrial fund ontology's website, which was also an effort of the community. So the key idea, and I think that would be great to see Ontology Commons taking those efforts and then putting them together and saying, look, now as a community, this is the place where we will go and share our stuff and have a certain governance that will be necessarily a different one than the one we have in agronomy or the one that exists in biology or biomedicine.
Okay, and there's a question there which I think was related to your talk. It was just basically how, what aspects of ontologies can make them more fair, but I'm guessing that OntoPortal itself makes ontologies more fair because they're more accessible.
You've seen in that slide that there was a few questions. We established 60 questions that were 65 that were based on the FAIR principle, that were based on different kind of research objects that are supposed to and we adopt them to ontologies. So that's going to be very soon published. There is a couple of pre-publication on this, but those aspects are very specific to ontologies also.
Okay.
And in order to investigate the FAIR aspect.
Okay, brilliant. Thanks, Clement. And that we'll be interested to see that when it comes out. Martin, you can see my questions there. I suppose, the first one is, and this is always a, they're kind of related, I suppose, barriers to adoption and then forming a coalition or a kind of a community around the ontology. Like, for example, for GoodRelations, what's your advice there in terms of bringing other people on board? Because, there may be an unwillingness to get involved. That could be a barrier. They may just see, ontology as being something kind of academic but less useful. But how do you get people, let's say, engaged in the community around the developing ontology, or giving you suggestions, or improving?
Yeah. Okay, so I think you need to distinguish in here whether you're talking about rather large domain ontologies that have lots of types that are linked to distinctions in existing data.
Yeah.
So for instance, a product types ontology.
Yeah.
Or more top-level ontologies. And while GoodRelations is seen as a rather application ontology by many, in a sense, it is actually a top-level ontology for e-commerce, because it also defines a model for quantitative data and distinction between products and services, very generic things. Now, when you want to build an ontology, in my opinion, the most difficult thing is, there are two difficult tasks. One is realizing that two things that share the same name in many industries are actually two or more different types. So you have the term book, and you need to disambiguate it and realize there are book titles and book copies and maybe even editions, but at least these two. And the second challenge is realizing that you have types or categories of entities that have very different names or in different contexts, but are actually the same type. For instance, you have human, you have hairdresser, and you have taxi driver, and you have teacher, but they are all in some sense agents. So like abstracting from this. In my experience with, and many people recommended the inclusion of domain experts in these kind of near top level definition of near top level categories. And I found that they're not very helpful, because you need a very specific expertise and training to be able to see both the both to be able to disambiguate types or to consolidate them. So the first thing is not so much consensus. You can probably win people, get them aboard your distinction when they see practical benefits. So for instance, GoodRelations made the distinction that products and offers are two things. That's actually the only real contribution by GoodRelations, and has likely been available in other conceptual models before. That products have no prices, but instead offers are promises to transfer rights on something for some compensation. So this is, you have something, you have a promise, and you have either money or a barter trade, not to put this in one. So this is a really specific expertise and skill, and this cannot be, this is orthogonal to consensus and adoption. It helps to have big players, but more like Google or Yahoo, because they signal relevance. Probably in social theories, there's lots about that. The second thing I would like to say about consensus is that if you are able to tap into existing consensus, that eases things a lot, and it makes the ontology more successful. For instance, if you already have a class of professor in the minds of human users, then having a class professor in an occupations ontology is easier to get consensus, and it's more effective because people classify and use it more correctly. So in a sense, we are not, the bottom line in here is, we are not free in shaping the conceptual elements in the ontology, but this happens in the context of data and human minds.
Yeah, and I think a related thing there, which you mentioned earlier on, was the ontology economics, where the smaller, I'm thinking of GoodRelations there, because obviously even distinguishing between products and offers, or products and transactions, or whatever you want to break it down into, it makes those chunks, if I can call them that, more reusable and easier for people to get their minds around and deploy in certain instances. So let's say it's a shop or whatever. So that, I'm sure there's probably something in terms of, there are some ontologies that cannot be small, but there are probably other ontologies that can be made into smaller reusable chunks that would make them more adoptable and more reusable. I wanted to see, we've about 5 minutes left. Maybe I'll ask a question of Gianmaria, and we see if we've time at the end for any other questions from the audience. Thanks, Martin. It's a related one, I suppose. It's about industry willingness to adopt ontologies, because you've been looking at different domains like space domain, automotive. The aeronautics is broadly related to the space domain. Has it been an easy? Have you been pushing on an open door? I suppose. Like, have the companies you've been working with seeing the reason for doing this, or is it more that you show them what can be done and then suddenly it becomes more compelling?
I mean, in the space system domain, I guess it's the word ontology needs to be explained a little bit less, because if you talk to a system engineer has already heard the word, and you kind of like have an easier way in. And then you start talking for a few months, and then you realize that actually you mean completely different things by ontology. And so there isn't even an agreement to what an ontology is between the academic community, the industrial community, and if you ask people that come from a computer science background, and they think of an ontology as a fancy schema, and if you talk to people that come from a formal logic background, they have a different kind of view of what an ontology is, and if you talk to people that are engineers, like mechanical engineers like myself, and come from a background of systems engineering, they have an even different view of what that is. And this is kind of like, it gives you a good understanding of how behind we are. It's kind of like a bit meta and a bit funny that ontologies are meant to these ambiguate terms, and the term ontology itself is still so ambiguous. It kind of gives you a feel for what the state of the industrial use is. But I guess if I want to be pragmatic, I'm a mechanical engineer by training. I've been studying this field now for about 2 years of application of ontologies to systems engineering and manufacturing, and I've looked at many publications, and then trying to explore the ontology related to this publication, and you end up realizing that they're very nice conceptual models, but there is a big disconnect. So RDF and OWL are really logical modeling languages, but unless you can connect those ontologies with the data, they're useless. And that's the problem.
Yeah,
that's the real problem. If you don't bridge that gap between knowledge modeling and data modeling, these things are nice conceptual, philosophical things that are not really useful.
Yeah, it's one of the key things to explain, that you've got obviously the model for the terms and the classes and so on, and then you've got the model for the data, and there's a linkage between those two. But that can be difficult, I think, for many to understand. Martin has shared a link to a book chapter on what ontologies are, which I think will be quite useful for many people in terms of even just getting that kind of message across. And I see as well that Nicholas had asked a similar question, or mentioned a similar comment about industrial readiness as being a key issue for ontologies, and one we need to solve. I might just ask the last question then, because we are close to our time, and that's first steps in terms of, let's say you are a company, you want to adopt an ontology. What's the first thing you do? So I'll address that to you as well, Gianmaria, since I have your name beside it there.
Okay.
Apart from get graph SF when it comes out.
Yeah, exactly. I guess the first thing you need to understand, what do you need these ontology for? So do you need a graph database schema?
Yeah.
Is that what you need? Or do you need something that reconciles a lot of different sources of data and does automatic categorization and that kind of stuff? And you really, like, that shapes what kind of language, because like the choices of how expressive you want to go. Like you need to decide if you, okay, do you want to go RDF, a triple store, what type of database to use, just like, and there is a trade-off between the performance of the database and the type of reasoning that then you can do in a type of language. I mean, it's so fragmented at the moment. That's the main issue, that like it took me 18 months to just find my way around like OWL, the different dialects of OWL, and then Shackle and Sparkle and Sparkle Star and Swirl and Swirl QL and all this stuff. That's the main. This is the main problem to industrial adoption, I think.
Okay.
And I guess you need to give these people a turnkey solution, otherwise it's never going to happen realistically.
Yeah, probably turnkey solution, but maybe even a kind of a quick one-page explainer saying, here's what these actually mean in an easy to understand language. Maybe Martin's chapter as he's linked to. Martin, you can answer that as well. I also want to invite Roberto to ask his question. So Martin, go ahead, and we'll ask. We've 4 minutes, I think.
Okay, very quickly regarding the ontology adoption in industry. Historically, data and structures and algorithms were linked. So we were used to define data structures with a clear understanding of the operations we want to run of the data. And the initial and still many in the ontology engineering community assume that with ontologies you can build data structures independent of, without defining the computational operations that you want to run on the data. And schema.org, for instance, showed that the better you know what kind of operations you want to run of the data, the more you are able to build a useful ontology. In a pure abstract sense, as an exercise, a philosophical exercise of modeling the domain, it will fail, not because it's too academic, but because a data model, a conceptual model, is a model, and the usefulness of a model can only be judged in relation to a purpose. Whether a model is too shallow or too rich depends on the purpose, and if you have no purpose, you cannot even say it's useful, so it's failed right from the beginning. And the technical choices, which formalism you use in all this is secondary. One last thing, if you talk about the industrial solutions, the effort for building an ontology is vastly underestimated. GoodRelations has, I think, 27, something like 30 classes, and it was a decade of my lifetime to design it and run it with many supporters. And second, good ontologies can be very, very small. So many people think they need hundreds or thousands of categories, but having one good distinction that can be preserved from some existing representation through the web or any data interoperability, then even a two-class ontology can be extremely useful.
But can I add something? I 100% agree, but the problem is that until we get it to a point where a person with a reasonable technical background can understand these things in an hour and produce an ontology in a week, there is not going to be industrial adoption. So how do we get there? Because I 100% agree with you that at the moment, you need 10 years to make something that is actually useful. But how do we get it down to a week?
That's a challenge, and maybe I think there's something in it in what Mark was saying there in terms of that tapping into the understanding that a person has about what a term is, as opposed to having other people do it. That those terms are resonate. The resonance there is the one. If you can get to that quickly, then you can get quicker adoption. So, if you look at the distribution of what terms are actually used in terms of the web, a very small number of ontologies, a very small number of classes having it's a long tail type thing, large number of the instances. But intuitively, it seems that there are probably terms that resonate with people. I want to move on to Roberto because we've been leaving him holding there for ages, so we only have 1.5 minutes. So Roberto, can you ask your question there, please?
Oh, thank you. It was more of a comment, supplement, if I may supplement the previous question. Regarding the ontology for space, that has been a topic, focus of mine for a while now. So if anyone is interested or has questions, please feel free to contact me. Today I had a presentation on it in an ESA workshop. So anyone, please contact me if you're interested in the topic. I'm aware of most projects on this. to supplement the points made about ontology senses, yes, there is a lot of confusion and different senses of the word ontology. In the IAOA at the moment, we're trying to clarify some of these senses and come to a greater understanding. But it basically you can look at the full spectrum of these knowledge organization systems, ranging from terminology lists to thesauri to taxonomies to ontologies. And like others mentioned correctly, besides the different senses, you have to identify a purpose and use cases to pick which resource or which system is most appropriate for the given situation. And it may not be an ontology; it may be something like a taxonomy or something less complex. So these are just some supplementary points I wanted to mention.
Thanks very much, Roberto. And what I'll do is I was just copying some of the comments there. What I might do is I'll give a mention to the space ontology when I'm doing my wrap up later on, because it might be that in the bigger session there might be others who might be interested. We're over time, I'm afraid, so it's been a great discussion. I think we could definitely talk for a few more hours. But thanks everyone. Thanks very much to Gianmaria, Martin, Clement, and all of our attendees, and Lan as well, our rapporteur. So we will leave it there, and I shall see you back in the main session again. Thanks everyone.
Thank you very much for the invitation and the organization.
Yeah,
thanks.
Thanks so much.
Thanks a lot.
It was a pleasure.
Now, where do we go?
Thanks for the invitation. It was really
thank you,
very
Martin.
nice and inspiring discussion
and great questions. And I think we got most of them, but perhaps again, I just want to copy them I'm going to copy them into a separate document just for my own interest in case there's things to follow up on. So thanks, Christina.
Thank you. Thanks all. We'll meet back at 4:25, if I'm not wrong. Yes, in the plenary room for the session summary.
That's great. Thank you.
Thanks. Bye bye.
I may not be able to be there for the main because.
Okay.
But thanks again. It was great to see you again.
No worries. And the sessions are recorded in any case, Martin. If you then want to check anything, we'll publish everything. Okay.
That's very nice. Thank you very much.
Thanks a lot.
Talk to you all.
You too.
Bye.
Bye.